Hi everyone. So this is group one, and now here I'm going to introduce the Android app we implemented for evo.2 to you. You can see on this page is the first page of our app, and you can try to what's gonna happen when I click the sign up button. So it's a new page. I can try to sign up. It's my name, some random password. And now it will show I can successfully sign up now. And now it also record what I've just written, what I've just typed. So I can just click login directly. And now I go to the next page, which is the page that we choose whether to create a new room or when we disconnect and try to reconnect to the Android app, and it will record all the rooms that we've already joined. So once we successfully log in, we can create a room, and I've created a room in advance, and you can see here is a room that you are already in. This player also joined in this room, so both of them can show the room name as test. So let me just create a new room. So here you can see we have different types of maps. You can clearly see its structure and how many resources, and it says on this picture. And let me just random pick one, and name it as test2. Once we successfully created a room, other players can just flash the page and see this room. So both of them have successfully joined this game. Since this map only requires 2 players to play, so it doesn't need to wait for more players, and the game started automatically. So in this page, we will choose territories. So for player 1, let's say the player for the left device is player 1, and for right device is player 2. Let's say for player 1, she will choose group 1. For player 2, when she tries to choose group 1, it will report an error. So she has to choose group 2. For each group, we have 3 territories. And now, at this page, we are going to assign some units to each territory. So this is a legal assignment. She can just click Finish button and go to the next page. And here, she has to wait for this player to finish the initialization to start the real game. For this player, let me try some illegal assignment. Okay, you can see the report. And if she tries to click the finish, nothing will happen. So she has to make an illegal assignment and click finish. Now both player both player can go to the next page, which is the real game. And this page, we'll need to, you can say, here is the round number, is the first round. Here is the map, and here is 3 different types of actions. So in order to clearly show our design, I've already finished several rounds of game. So now let me introduce each action one by one. Let me start from the done action. It's the most simple one. Once it click done, it simply means this player can no longer take any actions at this round. So no matter I click move or upgrade, nothing will happen. So it's the meaning of done. Next, I'll introduce the upgrade action. We actually have two types of upgrade action. First is upgrading some single units. Second, we can upgrade the maximum tech level. Let me try to upgrade the maximum tech level. Oh, So now we are at level 3, and if we want to upgrade to level 4, it requires more tech resources than we already have. So we can only upgrade some units. Let's go from 0 to 1. Let me confirm that. So this action will be recorded on the page, and you can see the updates. We now have a level 1. We now have a level 1 unit. Let's try some invalid action. So here we don't. The maximum tech level is lower than the target level, so it will report an error. Even if we the maximum tech level obeys the rule, if we choose too many units which cost us more tech resources than we have, it will also report an error. So all invalid action will be rejected by the server. So it's a upgrade action. So at this round, I believe this player should have enough resource to have an upgrade maximum tech level. Let me just upgrade it. So you can see it costs this player some tech resources to finish this upgrade action. And since upgrade maximum tech level action will take effect in the next round, so it doesn't show up on the web page now. Let me just click down for this player and click down for the left player. Oh, you can see the maximum tech level has been upgraded to 2, and you can see the tech resources and tech resource and food resource has been changed. It's because at the end of each round of game, we will get new resource from the territories the player can choose. So here is the next action is move and attack action. So it's a very simple action. Let's try a move action. Let's move from the mountain bell and to the north. We choose the unit we want to move, 6. Okay, it happened. And you can see there are some updates on the page. Let me then do some attack action. For the attack action, the source is the territory we control, and the target is the territory of our enemy. So here, let me just send 10 units to the target territory. So now we have 10 units with level 0, and we will use them to attack the destination territory. Let me just try to confirm that and click that. Okay, you can see on the page that we since we only have 10 basic units with level 0, and now out of the units we send lose their lives and the attacker lose. So here is a move action and attack action. So let us see the reconnect function. So now let me reconnect to the app again. On this page, you can see all rooms that you already joined in, and now you click test 2. So you can just go back and keep playing. For this player, also the same thing. Now both of players have reconnect to the game that they already joined in. Also, since now a single player can join different rooms, she can also try to join some other rooms. Okay, here you can see this room is at round 29, and this room is at round 8. So it's two different rooms.
UML diagram for evolution 1. We separate this project into 2 parts. One is the client, and the other is the server. And the following diagram is mainly about the server. In the server, the main class is the game. It mainly handles the communication coming from the client And one key class is game controller. It decided the map we use and validate the action from user and also determine the game end or not. And inside the class player, it has the attribute of colors, and it also has some territories. And in the territory class, it has attribute as neighbor and unit. We also have an interface for action, and then the attack action class and the move action class actually implements the action. This is the UML for Evolution 2. We move on to Android for GUI, and the class here represent the Android client. Since most of the calculation is done at the back end, so we will focus more on the game server here. So in Evolution 2, we introduce the new class user. It got name, password, and the room he has joined. We also introduce a room class here. So right now the game is bind to a room. For Evolution 2, we have a new world map. Right now it has the attribute of size, food, and tag. We extend the player class. So right now the player has food, tag, and is connect or not to handle the reconnection issue. We also extend our territory. So the territory has food and tag attribute. We also implement a new update class. So it can actually do the update action for the original interface. So basically for Evolution 2, we extend some class, introduce some new concept, and also implement the action interface with the update. We introduce the MVC patterns to our Android client. Here, the activity is the actual models. The adapter is the controller, and the UIs are wheels. So this pattern is really good, and our Android client is going well. We use affordance and signifiers in our UX design principle. We have a room name here, indicating that you should input the name of the room. And what will a user do when he sees a blank space? He will try to scroll up and down. And we support this kind of function. The user will be very comfortable with this kind of operation, and then he clicks on the map he wants, and then we change the map according to his operation. And this is kind of an affordance.
Hi all, welcome to the third part of our presentation. First, we will talk about the features we choose. We choose chat and alliance from group 1 and resilience and persistence from group 2. For the self-proposed one, we don't make the final decision yet, but currently we will want to add an audience feature to our game. In Evolution 2, there will only be a fixed number of players in one game. In this evolution, we want to introduce the audience. There is still limit players in one game, but will be unlimited audience. By the way, audience means you can join the game but cannot prefer any actions, can only see the whole process of the game. And thanks to the time we spend on designing, it will not be that hard to accommodate these new features. Because we use multi-threading for each game, more specifically, we will create a separate thread for each player. So to add the in-game chat, we only need to create a new thread in each game which dedicated to communication. It will receive any chat message from any client and resend it to the corresponding player or broadcast it to all players in current room. To make the code more flexible, we also have an interface for all actions. So to add the new alliance action, we don't need to change too many current code. What we need is create a new class called alliance action, which implement the action interface, and then we are almost done. However, there's still some tricky thing, especially for the persistence part. In evolution 2, we only use a little bit of database and write row circle by ourselves. So it will be very difficult to store some complex data structure like the map we are playing or the room info. So we need to use some ORM library like Hibernate in Java to accommodate this feature. And based on our discussion, the biggest challenger from evolution 3 will be the resilience part. We not only need to reconstruct the whole game by reading the data from database, we also need to somehow notify the client about the server is done, and ask them to reconnect to it. And for now, our group has finished about 60% of the chat and alliance feature and just start working on the persistent part. For the audience feature, because we don't make the final decision yet, so we are not started. What we learned from evolution 2 is that from user perspective, you should introduce more automatically function. For example, once you choose one territory, the data of all related drop-down menus should also be updated. This makes more sense to the user and also guarantee he or she has no chance to input some invalid data. And one more thing is UI also has some scalability. The UI we designed in Evolution 2 only supports 5 actions. Now we need one more. So to accommodate this new action or maybe even more actions in the future, we change the action related UI a little bit to be more scalable about the number of actions. So that's all for part 3. Thank you.